Here's another example of how we can use composite functions and properties of functions in just solving basic problems. Many students have a lot of trouble when it deals with graphs. I've found this when teaching for 15 years. How do you use a graph, Mr. Kutcher? How do you use a graph? Well, just use it like a normal function. If you understand that functions are made of points, inputs and outputs, all we're going to do is we're going to either add, subtract, multiply, divide, or compose those points within each other. Example. We have where we're asked to take two functions, f, which I'll outline in red. You can see that right here. F right here. And we have g, which is I'm going to outline right here. You can kind of see that. All right. Where we're going to add them together and create a new function, f plus g of x. Now this is not multiplied by x, and a lot of students think that. This is actually simply f of x plus g of x. So to do this, we're going to take f of x, okay, and we're going to take all of its values, all right, from 0 to 3, and we're going to add them together. So in this case, when you have this right here, we're going to just make a little table, and this is how I would do it. I'm going to have x, and we're going to take from 0, 1, 2, 3, all right, all the way down there. And we're going to take these, because they're common values, we're going to add, because honestly, these mean the y values. So we're basically taking the y's, we'll call it y1 of f, we're adding those to the y2's of g for the corresponding x value. So for example, we look at 0. 0, we see that we have an f value right here, which is at 2. So we take 2, and we're going to add to our g of 0, which is negative 1. And what we have then is going to equal 1. We do the same thing for 1. We take a look at 1, and we say, okay, what's the value of 1? Well, for f, it's going to be 3. And over here at g, it's going to equal 0. And we add those together, we have 3. So now we have an ordered pair of 1, 3. We then do 2. All right. Now, if you're wondering, why can't we do other points? Well, we only take points that we know we can actually see. All right, true values. It's the easiest to do when you're dealing with graphs. And so we see another one at 2. Here, f, we see it's 1, or pretty close to 1. And over at 2, it's kind of hard to try to lay it out, but we'll say that right here that equals 1/2. So we'll put 1/2 for g, and that's going to give us 3/2. We do the same thing at 3, and we realize we have 2 plus 0, which equals 2. From here, I'm going to draw this graph in, we'll keep it in blue, all right? And so we'll plot those points, and I'll just get rid of this right here, okay? And we have a point at 0, 1, big dot. We have another point there at 1, 3, big dot. We have another point there at 2 and 3/2. 2 and 3/2, which would be right about right there, big dot. And we have another one at 3, 2. 3 and 2. And there's some that overlap. Connect dots, la la la. All right, and we have that as our new function. I'll line it, highlight it a little bit. Let's highlight it here, and we see this is our value, and that's our new value. This is our new function. Now, with this, we can also take and look at the values, all right? And using g, and we can do different properties. We can find those values, just like we did before. In here, we have f composed, this is composition, composed of g at 1. Now, this is the input, all right? This is the input. It's not the multiplication. So we have f composed of g of 1. So what does that mean? We're taking g of 1. So we look at g of 1 right here, which is 0. So that means we're finding f of 0. It's kind of a game. Just keep on going through and just find these different values. So look at f, and we see that it's the red one. Remember, it's not red. All right, and we just look at g of 0, which is 2. So our value is going to equal 2. So f composed of g of 1 is 2. We can go the same thing, and now we can figure out what g composed of 3 is. G composed of 3, or it's g composed of f of 3, I apologize. What is that? Well, first we find an f of 3. Go to f, look at 3, and it's going to equal 2. So now we find g of 2. What is g of 2? G of 2 is 1/2. So g composed of f of 3 is 1/2. Easy. Let's try another one. f, now once again, this is f of 1, you have to distribute that through, is minus g of 1. It's now multiplied, all right, by 1. So we look at f of 1. All right, f of 1 is, f is 3 minus g of 1, which is 0. And that equals 3. And we keep on going. This is f over g of 2. Once again, not multiplication. It's f of 2 over g of 2. Some students say, why do they write it like that, Mr. Gottschalk? Well, it's just the way it is. All right, it's an easier way of writing notation for functions. So in this one, we see f of 2. F of 2, we look at our graph, and we see f of 2 is right here, there, which is equal to, oops, wrong one, sorry. F of 2 is right there. I looked at the wrong graph. All right, which is right there, which equals 1, over g of 2, which is 1/2. And then we take 1/2 over 1, or sorry, 1 over 1/2, which happens to be 2, and that is our final answer. So, another tutorial on how to use graphs of functions and simplifying them and doing whatnot. The key thing is understanding every function made up of inputs and outputs. Whatever's inside the parentheses is the input, and you have to find the output. The inputs do not change. All right, it's the outputs that change depending on what you're doing with the various functions. I hope this helps you out with your homework and understanding composites and how they relate with graphs and functions and all that cool stuff. All right, talk to you later.